All right, today we're going to get working on the week 2 notes, which is on page 13 in your workbook. So you'll see this exact format on page 13 in your workbook, starting off the week 2 notes. So we're going to do a quick review of PEMDAS that you learned in the week 1 notes. So it says in the directions to substitute, or in other words, plug in the given number for the variable, or in other words, the letter stated. This will be used as a check for future problems throughout these weeks of notes. So you really want to know how to substitute in. Again, we're going to refer to it as a check later on, and you'll see what we mean when we get there. But you also have to make sure you are using PEMDAS. So number 50 says to evaluate, in parentheses, 10r minus 3 all squared when r is equal to -2. So again, we're back to this, where an r value is given, there's an r in the expression. What you have to do is take that value and plug it in where you see an r. Everything else comes down. So the parentheses come down, the 10 comes down. In place of r, I'm going to plug it in with parentheses. I don't think we really did a lot like this. I'm using parentheses to signify multiplication. When you have a number and a letter next to each other, like 10 and r, it means that they're being multiplied. They don't put a symbol there because it's a number with a letter, and the symbol is unnecessary. But you just can assume when you see a letter next to a number like that, with its coefficient being the number, you just are multiplying them together. So when I plug in the -2 for r, I show that they're being multiplied with parentheses. You can use a dot if you prefer. It is entirely up to you. Okay, then I bring down the -3. I bring down the squared. So that's everything. Now, we definitely haven't done one like this. We're going to start with the P in PEMDAS, which is parentheses, and there's a lot going on inside of the parentheses here. So I'm using the red to show what I'm going to work on first. Everything inside of the red needs to be done first. Now, inside of the parentheses, we have multiplication and we have subtraction. So you're kind of doing PEMDAS, again, within the first step of PEMDAS. So in the parentheses, you have to follow the rules of PEMDAS, those order of operations as well. So multiplication comes before subtraction, so I'm going to do that first. And I'm going to bring my parentheses down because I won't be done yet. So I'm going to do this multiplication first. So 10 times -2 is -20. And the -3 comes down, and so does the squared. Okay, now I'm still not even done with my P parentheses step in PEMDAS, so I need to finish that off by doing what's inside of the parentheses again. -20 minus 3 is a -23, and that's being squared. Not sure if you remember from the previous video, but if you plug it in like so into your calculator, which I imagine many of us have to plug in what 23 squared is, if you plug it in with the negative without parentheses around it, it will give you the wrong answer. You need to keep these parentheses, or you can plug in -23 times -23 into your calculator. Either of those two options will give you the correct answer, which in this case is a positive 529. Okay, you will always get a positive answer when you square a negative. So that process that we just went through, where we took a number and we plugged it in for a variable to check it out, that's what we're going to be working on when we're checking these problems coming up. Okay, so what we're going to be doing for the rest of this week's notes is solving equations. So the whole goal of solving an equation is to get the variable by itself. So like you have this long expression and your answer is going to end up being x equals something. That's how you know you've solved the equation. When you get it down to x equals, or you get the variable alone, that's your overall goal, and that's how you know that you are done. Okay? So you are always going to work on getting that variable by itself to ultimately solve the equation by doing opposite operations to both sides of the equation. So I'll explain what I mean by that after I go over this whole idea of an equation. So an equal sign is kind of like this balance beam scale here, where the left side is equal to the right side to maintain that balance. That's what you want to be thinking about while you're solving these equations. You have to maintain that equal sign, or that equality of the left and the right side. So if you look at the right side of this scale, there's 1, 2, 3, 4, 5, 6, 7 dots. On the left side, there's only 3 dots, and then there's an x. What would that x need to be in order to be equal to the 7 dots over here? That would be x equals 4. There has to be 4 dots right here that when added to 3 would end up getting you 7. So that's a really long stretch, but kind of gives you a visual of what solving an equation is. What this equation would look like would be x plus 3 equals 7. So something, that x value that's in the problem or on the scale, plus the 3 dots that are already there, should be equal to the right side, which had 7 dots. So what I mean by using opposite operations, I know that looking at this equation, probably all of you, if not most of you, can very easily figure out something plus 3 equals 7, that something has to be 4. But we are going to get into tougher equations, so I want to go through the process of how to go through this. So that opposite operations idea, your goal is to get x by itself, and right now we're adding 3 to x. The opposite of adding 3 is subtracting 3. So you're going to subtract 3 from both sides, and that's going to cancel out. That's the whole idea of doing the opposite, is your goal is to get x by itself, so you want that extra stuff that's with the x to cancel out, and it'll cancel out by using opposites. So now that that's gone, the x comes down, and I'm left with 7 minus 3 on the right side, which is 4, and I get the right answer. So again, like I said, I know you guys are capable of figuring out whatever, x needs to be plus 3 equals 7. Obviously it's 4. But for these next few examples, we're going to go through some basics that you could probably do in your head just to go through the process so that when they get more difficult, you're an expert at the process. Okay, so the directions for the next part is solve the following examples and, for the following examples, solve and check. So for 51, I notice that I have an x. My goal to solve this equation is to get x by itself. To get x by itself, I have to get rid of the plus 2. The plus 2 is the only other thing that's on the left side of my equal sign with the x. To undo plus 2, I subtract 2, just like I did in that example I wrote above. Because 2 minus 2 is going to cancel and just leave you with an x. The equal sign comes down, and 28 minus 2 is 26. And that's your answer. We have solved it because x is by itself. The check is going to use substitution. So now that I know what x is, I can take that. So my original equation was this. I can take that 26 and plug it in, and it should work. And what I mean by work is when you do the math over here on the left side, 26 plus 2 is 28. It's equal to 28. It works in the equation. Your whole goal is to figure out what x needs to be so that the equation holds its equality or holds true. Okay, 52 is the next problem down. So this one's a little bit trickier, but to solve for x, with the equal sign being where it is, we just have to get rid of the 3. The 3 is the only thing keeping the x from being by itself. Now remember what we said in the beginning of the video today. When you have a 3 and an x next to each other like that, it means they're being multiplied. To undo times 3, you have to divide by 3. It's always going to be the opposite. Here's what happens, and it's kind of a cool trick. They do technically cancel, and I'll be canceling them for the rest of the lesson. But 3 divided by 3 is just 1, and 1x is just x. So that's why they technically cancel, even though they don't cancel, they just cancel out to be a 1, and that 1 is invisible. It can be invisible. Okay, and then negative 9 divided by 3 is a negative 3. So that just means that x is equal to negative 3. When I go to check that in the same way that I did the last one, I'm just going to rewrite the original again. But I take my answer and I plug it in for x. So it's going to be 3 times negative 3 equals negative 9, and that does check out because 3 times negative 3 is negative 9, and that's equal to negative 9. The checks, I will tell you right now, you don't need to ever check. I'm not ever going to give you a quiz or a test that says solve and check. The benefit of checking is you're guaranteeing that you got your answer right. It happens sometimes where you make a mistake, like maybe you said it was a positive 3, and it happens. But if you check it, you would see that it was wrong and you would go back and fix your answer. Ideally. At the next one, here's my equal sign. So I'm trying to get x by itself. The only thing that's also on the left side of my equal sign with that x is a minus 5. How do you undo a minus 5? You add 5. So I'm going to add 5 to both sides. And just to go over again why you would need to add 5 to both sides is to hold the equality. If I add 5 circles to the left side, you have to add 5 circles to the right side, again, to maintain that equality. Just like if I took these 3 circles away, I'd have to take 3 of these circles away so that the balance maintains. So I add 5 to both sides, for example, 53. That cancels my 5 out, and I'm left with x equals on the left, which is awesome. And then 36 plus 5 is going to get me 41. Okay, a quick check of that. I'm just going to rewrite the problem. You can even do checks in your head if you want, but you would just be plugging that 41 in, minus 5 will get you 36, and that's absolutely correct. 36 equals 36, and we have done it correctly. All right, last one is a little bit tougher because of the fraction. I will tell you, you're not going to deal with a lot of fractions in this course, but I definitely want to show you a couple of them. So over here, again, we're trying to get x by itself, but we have 1/2 in front of it. So technically, x is being multiplied by 1/2, and the opposite of multiplying is division. But we don't divide by 1/2. That just looks ugly. It's just not something that we do. So I want you to think about it. If you're multiplying something by 1/2, you're taking half of it. What operation better fits taking half of something? It's division. Taking half of something can easily be found by dividing that something by 2, cutting it in half. This is ultimately just x divided by 2 equals 12. Multiplying by 1/2 and dividing by 2 is the same thing. So if this is being divided by 2, the opposite of dividing by 2 is multiplying by 2. So to undo the divided by 2, I'm going to multiply by 2. And the reason that that works is because 2 times 1/2, think about it, half of 2 is just 1. So I get 1x, just like I did in a previous problem. And then, oops, I have to multiply this side by 2 as well to maintain that equality. And that gets me 24. So x is equal to 24. So a nice little rule that works no matter what fraction you have is to multiply by the reciprocal, also known as the flip of a fraction. Okay, so for example, we had 1/2 in the problem. We multiplied by technically 2/1, but 2/1 is just 2. That would be the flip. You just flip the top and the bottom. If you had 1/3 x, you would multiply it by 3/1, and those would cancel. You can always multiply a fraction by its flip, and it'll ultimately cancel out. I'm going to do the check in my head. I'm not even going to rewrite it just to show you that that's nice and easy. 1/2 of x, which is 24, equals 12, so that means half of 24 is 12, and that is absolutely true. If I multiply 24 by 1/2, or in other words, divide it by 2, I will get 12. So it checks out. Okay, so again, what we just did for those 4 examples was we went over like the basic methods for solving. They are going to get a little bit tougher. So we're going to start moving into solving 2-step equations. So you're going to use those same ideas as we did in the last few, where if you have addition, you use subtraction to get rid of it. If you have multiplication, you use division to get rid of it, and so on. But if you look at this first example, 55, we have 2x plus 3 equals 9. So if I just draw this line to kind of show you the left and the right, I'm trying to get x by itself. There are now 2 numbers in the way. The 2 that's being multiplied to the x and the plus 3. This does not follow PEMDAS. I cannot stress that enough. Solving equations does not follow PEMDAS. You do not take care of multiplying and dividing before you take care of adding and subtracting. It's actually the complete opposite. So it says right here, in the directions, you're going to use the same process as 1-step equations, but you add and subtract first, then you multiply and divide. That's so important. So I cannot tell you how often you are going to see the format that you see on this page where you have a number multiplied to x and then a number added to that as well. I call this like our basic form for solving an equation, because when we get into even tougher ones than this, you're going to want to get to this form because you're going to get so used to it over time, you're going to know exactly what to do. Okay, so I need to get rid of what's being added or subtracted first, which in this case is the plus 3. And to get rid of it, I'm going to subtract 3. And I subtract 3 from both sides, again, to maintain that equal sign. What you do to one side, you have to do to the other. So 2x comes down. The 3's are gone, so I just bring down the equal sign, and 9 minus 3 is 6. Okay, x is still not by itself. That's how I know I'm not done. So now I need to get rid of that 2. It's the last thing over there in the way of x being by itself, and they are being multiplied. So to undo the multiplication, I divide both sides by 2, and 6 divided by 2 is 3, and that's my final answer. For the check, I'm going to do exactly what we did on the last page, where you take your answer and you plug it in for x just to make sure it works. So I need to plug in a 3. This is going to be 2 times 3, and everything else just comes down. And I need to simplify the right side. So you multiply first. 2 times 3 is 6, and the plus 3 comes down. And 6 plus 3 is 9. So 9 equals 9, and that does check out. So that means that your answer is correct. But there is some more room for error as these get harder. So you definitely want to try and check whenever you can, though it will never be mandatory on a test or a quiz. All right, next one, kind of the same setup. Notice your equal sign is still here. It's a y that we're solving for, but still no different. We're just trying to get y by itself this time. And there's a negative 2 and a minus 7 in the way. The negative 2 is directly next to the y, which means they're being multiplied. Even though there's a minus sign in front, it serves as a negative. It's a negative 2 times y because there's no other symbol between them. So to get rid of what's being added or subtracted first, like the directions tell me to, I have to get rid of that minus 7 first. And I'm going to do so by adding 7 to both sides. So the negative, the 2, and the y all come down. The 7's have canceled, so I bring down my equal sign, and 3 plus 7 is 10. Now those are being multiplied, so to get that y by itself, I have to undo that multiplication by dividing both sides by negative 2, and I get y is equal to negative 5. Now take a second to just compare what we did from 55 and 56. First, we got rid of what was being added or subtracted. Then we divided by the number that it was being multiplied by. It's that same method every time, which is kind of what's nice about solving equations, is once you've got it, you've got it. So now I go to plug in that y. So it'll be negative 2 times negative 5 minus 7 equals 3. You just simplified that left side, sorry. First I multiply negative 2 times negative 5 is 10. Bring down the minus 7, and 10 minus 7 is 3. So I get 3 is equal to 3, and that checks out. Okay, so at this point, I'd like you to pause the video and give 57 a try on your own. Now I'm going to start going over it. So hopefully you're coming back from doing it yourself. The answer to 57 is x equals 7. If you got that, awesome. If not, absolutely pay attention to this. So my equal sign's right here. I'm trying to get x alone. I need to get rid of the minus 7 and the negative 3. It's a lot like the setup of the last one. So to get rid of the minus 7, because you always get rid of what's being added or subtracted first, I'm going to add 7 to both sides, and those will cancel. I'll bring down my minus 3x, my equal sign because my 7's canceled, and negative 28 plus 7 is a negative 21. X is still not alone. It's being multiplied by negative 3, so I divide both sides by negative 3. So those technically cancel or leave me with a 1, but I don't need that 1 there. And then negative 21 divided by negative 3 is 7. So I get x equals 7. See, this one's not asking you to check. Obviously you can, you don't need to check. All right, number 58, same kind of setup. I have a number being multiplied to the x and a number being added to it. The x is right here. Now be careful, this one switches the order a little bit. So if you're trying to get rid of what's being added or subtracted, take a second to see which of those two numbers, the 1/5 or the 4, are being added to the x. Hopefully you're thinking 4. I know these terms are usually flipped and the x is written first, but just not in this case. The 4 is being added, so that is the thing I need to get rid of first, and notice it's a positive 4. There's no symbol in front of it. So to get rid of positive 4, I'm going to subtract 4 from both sides of my equal sign. So that the 1/5 x comes down, the equals comes down, and -1 minus 4 is a -5. Now remember that hint I gave you in the last page about getting rid of a fraction. To get rid of a fraction, you multiply by the reciprocal, or otherwise known as the flip. So I have a 1/5. The flip of 1/5 is 5/1. 5/1, guys, is just 5. So I'm going to multiply both sides by 5, and that's going to cancel that out because 1/5 of 5 is 1. So it leaves me with 1x, or just x, and -5 times 5 is a -25. All right, this last one has too many fractions to do. I promise you're not going to see anything like that on a test or a quiz. If you want to challenge yourself and give it a try, my answer key is posted on Blackboard so you can check your work, but you should get an answer of w equals 4. So if you want to give that a try, absolutely go for it, but you won't see anything like that in these in the tests or quizzes in this course. So we're just going to flip on to the next page. I'd rather you focused on these kinds of problems. That's why I skip stuff like that. There's also one like that with all those fractions on your homework. Don't worry about practicing that. You will not need to know it for tests and quizzes, like I said. All right, so on the last page, you worked with this basic form where you have a number being multiplied, a number being added or subtracted, and you have to get rid of both of them. That's what's going to happen in these future examples, but there's an initial step before you can get to that basic form. So this page is all about solving equations by combining like terms. So we went over combining like terms in the week 1 notes video. Essentially, like terms are just terms that have the same letter and exponent. So if you look at number 60, well, actually, I'll just go over this real quick. It says simply combine like terms to simplify whenever possible. So if you look at 60 right now and you're trying to think, I have to solve this equation, which means get x by itself, and you're like, oh my gosh, there's 2 of them. That's going to make it a lot harder, okay, unless you combine your like terms. You might be freaking out seeing 2x's, like I have no idea how to solve when there's 2 of them. Just combine them. So you can combine these like terms. X and x are like terms, so 3x plus 2x is 5x. Bring down the minus 10, and the equals 15. And you'll notice right away after combining those 2 terms, boom, boom, you're in that basic form, the one that we just worked with on the last page. So here's my equal sign. You always get rid of what's being added or subtracted first, so I'm going to undo the minus 10 by adding 10 to both sides, so that negative 10 plus 10 cancel out, and I'm left with 5x, and my equal sign comes down. And then 15 plus 10 is 25. Okay, x is still not alone. That's how I know I'm not done. X is being multiplied by 5, so to undo times 5, I divide by 5. I keep doing that. Divide by 5, so those 5's cancel, and then I get x equals 25 divided by 5 is 5, so my final answer is 5. Now again, you never need to check, but if you wanted to check this one, you can check it in this equation after you've combined like terms, or the better option is to always check it in your original, and you just have to plug it into both of those. So I'll just show you one check for an example like this. It would be 3 times 5 plus 2 times 5 minus 10 equals 15. You'd simplify the left side, so I'm going to do my multiplication first. That's 15, and that's 10. And then notice 15 plus 10 is 25, and 25 minus 10 is 15, so it ends up checking out. So sometimes the check is a little bit of work. Definitely try and do it whenever you can, because you will guarantee you get them correct. If you notice, this week 2 notes is all solving equations. So the quiz that you have on the week 2 homework assignment is going to be all solving equations as well, and you can check every single problem. So you can basically guarantee yourself 100 on that quiz if you go through and take the time to check all of the questions. Okay, number 61, kind of the same setup. So I'd like you to, again, pause the video and give this one a try on your own. Okay, Hopefully you're coming back from pausing right now. I'm going to go through and go over it. The answer to 61, if you just want to know if you got it right, is -3. Okay, so to go over this one, I'm going to start by combining my like terms. That's a minus in between them. So 6x minus 3x is 3x. My -9 comes down, and so does my equals and my -18. There's that basic form already. All you have to do is combine like terms and you're there. So you get rid of what's being added or subtracted first. To undo a -9, I add 9 to both sides. So the 3x comes down, the equals comes down, and -18 plus 9 is a -9. Remember, you're still not done because x is not alone. Right now, x is being multiplied by 3. So to undo that, I divide both sides by 3, and I get that x is equal to -3. Boom. Just like that. All right, number 62 is kind of backwards with the way that it's written. So notice the 33, the number that's by itself is on the left side, the equal sign's right here, and then your variables are on the right side. So I'm going to go through this with you. Still, what I do notice when I see where my variables are is that there are 2 of them. So the first thing I need to do is combine my like terms. And remember, I combine my like terms because they're both combinable. They're on the same side of the equal sign, and I can very easily just add them together. Okay, so -6m plus 3m is a -6m. Then if you notice, I also have a -4 and a -5. I can combine those as well because, again, they're on the same side of the equal sign. Why would I want 2 numbers when I can just combine them and make this easier? So -4 minus 5 is a -9, and I'm going to bring down this 33 equals. Now, I know it's still backwards, but this is that basic format where you're trying to get m by itself. It's being multiplied by -6, and it has a -9. So to get rid of what you're adding or subtracting first, which would be the -9, I'm going to add 9 to both sides so that that cancels out. 33 plus 9 is a 42. I bring down the equals, and I bring down my -6m. Because they're being multiplied together, I get rid of the -6 by dividing both sides by -6. And I get that -7, which is 42 divided by -6, is equal to m, and that is my final answer. Now, if you're not very comfortable with solving equations and that was uncomfortable for you to have the letter on the right side, honestly, I've been solving these forever and I still don't like to have the variable on the right side. It just feels weird. You could, in the very beginning, rewrite it. I think that's a plus. Yep. -5 equals 33. You can just rewrite it by switching the sides. It doesn't change anything. It's like rotating the beam to be backwards. It's still equal. The left side equals the right side equals the left side. So you can switch the order if that makes it a little bit easier for you. And then combine these same way, -6m minus 9 equals 33. Still solve it by adding 9 to both sides. -6m is equal to 42, and then divide by -6, and you get m equals -7. It's still the same method, but if it makes it just seem a little bit better to you to have the m on that side, just take a second to flip your equation around. Okay, if you haven't seen it yet, your code word is right here, buffalo. Buffalo, or you got that buffalo spirit today. Code word is buffalo. All right, moving right along, solving equations using the distributive property. So the distributive property is not something we've gone over in this course so far, but hopefully it's something you've at least been familiar with in the past. Distributive property is multiplying a number among more than one term. So multiplying to more than one term. Okay, and the best way to learn distributive property is through examples. So if you look at number 63, 2 is on the outside of the parentheses. Remember, parentheses mean multiplication. But look, notice where the parentheses end. They end after the 7. There are 2 terms in the parentheses here. That means that that 2 is being multiplied to both of them, so you have to distribute the 2 through to both of them and use multiplication to figure this out. So it'll be 2 times 3x, which will get you 6x. And then the 2 times the 7 is a plus 14. That would be the distributive property in its most basic form. You take the number that's on the outside and multiply it through to everything to follow inside of the parentheses. Okay, the next one's kind of the same idea. It's 4 times, but it's 3 terms on the inside of the parentheses. So you have to multiply that 4 by this term, and this term. So just take it piece by piece. First, 4 times 3x squared. Just multiply the 4 times the 3. That'll get you 12, and the x squared carries over. 4 times negative 9 is a negative 36, and the x just carries over. And 4 times 1 is a plus 4. It's really just multiplication, but you have to make sure you multiply through to everything in the parentheses to follow. All right, next one's a little bit tougher. I have to distribute this 5 through, but notice where the parentheses are. They start here, which show that the 5 is being distributed through, but they end right here for the 5. So the 5 is being distributed to the x and to the 7, and then it stops. So when I distribute that through, I get 5 times x, which is just 5x. Remember, there's no symbol between them, so you can just write 5x. And then 5 times 7 is a positive 35. But then notice you're not done. If you look, there's also a positive 2 that's being distributed through to the x and the negative 4 because there's 2 terms after the 2. So I multiply that 2 through to both of them. A positive 2 times x is a plus 2x, and a positive 2 times negative 4 is a negative 8. Now, as well as we distributed this, we're not done. You always want to simplify any chance you get. So I can combine like terms here, which means I can simplify it further. There's a 5x plus 2x, which is 7x, and then a positive 35 and a negative 8. They're just numbers, so they're definitely like terms. When I add them together, I get plus 27, and that's as simplified as this gets because I cannot combine those any further. Okay, so just a little note, you always simplify. Even if the directions don't specifically say simplify, you want to make sure your answer is always in simplest form. All right, so let's try a couple of solving equation examples using the distributive property. Remember, your goal is to get to that basic form, which we've had a lot of practice with so far. So 66, actually before we do that, let's go over this hint real quick. The hint is to always distribute first. If you see the distributive property, no matter what example we're doing throughout this course, you do it first. Okay, so number 66 has the distributive property. 3 is being multiplied by x plus 5. That's 2 terms in there, so I need to distribute the 3 through to both of them. So 3 times x is 3x, and 3 times 5 is a plus 15. What did I do? Oh my god. I don't know why everything's highlighted, but we're just going to keep going. So plus 15 is equal to a 45. Okay. So you notice right away after doing the distributive property, this is that basic form where we're trying to get x by itself. You have to get rid of what's being added or subtracted first, then we'll get rid of that 3 that's being multiplied to it. So to undo the plus 15, I'm going to subtract 15 from both sides. So those cancel out. The 3x comes down, my equals comes down, and 45 minus 15 is going to get me 30. And notice you're not done, you're still trying to get the x by itself. What is going on? So x is being multiplied by 3. I'm going to divide both sides by 3 to maintain that equality. It's always what you do to one side, you do to the other. And since those 3's canceled, I am left with x by itself. My equal sign comes down, and 30 divided by 3 is 10. So just like the last one, I'll show you one check so you have an idea of how you would want to do it. So this is the original given equation. If I take that x value that I got as an answer and I plug it in for 10, it's going to look like this. And then I follow PEMDAS. So I'm going to do what's in the parentheses first. So the 3 comes down, 10 plus 5 is 15, and that equals 45. And then 3 times 15 is 45. So 45 equals 45, and that checks out. See, the checks can go rather quickly, and it's definitely worth your time to do them. All right, number 67 is actually the last one we're going to do, and I'd like for you to give it a try. So pause the video at this point and just give it a try on your own. Okay. Hopefully we did well on this. Number 67, the answer is x equals 9. So I'll go over that with you. Here's your equal sign. The 3 is on the outside of the parentheses being multiplied through to both of the terms because it's the parentheses signify multiplication and there's 2 terms in there. So 3 times x is 3x and 3 times negative 2 is a minus 6. And that equals 21. I'm back to that basic form. You're going to love this form after a while. So I need to solve for x by getting rid of what's being added or subtracted first. So to undo minus 6, I'm going to add 6 to both sides. So that the 3x comes down, the equals comes down, and 21 plus 6 is 27. My last step here to get x by itself, since it's being multiplied by 3, I'm going to divide both sides by 3, and you get x equals 9 because those 3's cancel out, and 27 divided by 3 is 9. So notice, same thing with 66 and 67. You start by distributing because you always distribute when you see that first. Then you wanted to get rid of what was being added or subtracted. Then you divided by what was being multiplied by x and you got your answer. So it's the same process over and over.